All right, so now we're going to look at a quick video clip on the Earth's tilt and then continue with our notes.
The yearly trip around the sun helps create our seasons. Earth's axis is tipped a little. It tilts like this. As Earth circles the sun, the North Pole leans towards the sun during part of the year and gets lots of sunlight. This gives the Northern Hemisphere its summer. Half a year later, Earth is over here, and the North Pole leans away from the sun. Now the Northern Hemisphere gets less sunlight and has winter. The Southern Hemisphere of Earth has the opposite seasons. During the North's winter, it's summer in the South. People once thought seasons were caused by changes in the distance between sun and Earth. Now we know that it's the tilt of Earth's axis. So Earth rotates once a day on its axis and orbits the sun once a year.
All right, so that's a big key thing. One, the Earth's tilt is the reason for the seasons. It is not the distance it is from the sun. It's all about how much direct sunlight the Earth gets from the sun. So, as we talk about in that first part of our notes, during the winter, the opposite is true. The Northern Hemisphere tilts away from the sun and receives less direct sunlight, less thermal energy, causing winter. So what happens in the Southern Hemisphere? Well, you guessed it. Seasons are opposite in the Northern and Southern Hemispheres. If one hemisphere is tilted toward the sun, the other hemisphere is tilted away. When it is summer in the United States, it's winter in Australia. Students there are having their longest vacation in December and January because it's the summertime. That way they can enjoy the summer weather. Now, what about the people that live closer to the equator? Well, what's their weather like? Or their temperature like? Well, the equator, or the area around the middle of the Earth, also has seasons. Because the area is far from the two poles, it never tilts very far, or it doesn't tilt very far from the sun. As a result, the weather stays warm all year round. So at the equator, this means that winter near the equator looks very different than the winter we're at. The seasons in this area are usually wet or dry, not warm and cold. Right? So the equator has more wet and dry seasons versus warm and cold. So seasons are patterns that we then see in what occurs throughout the year. So let's jump to our notes. So opposite seasons in the northern and southern hemisphere. Yeah, when we have winter, southern hemisphere has summer. So let's carry on with our notes here. So the equator has seasons. They do, but not big temperature changes. Just a little change in the tilt for the equator area. So their seasons are wet versus dry, where ours are warm and cold. The equator is wet versus dry. Jump back to our reading. So, what would most likely happen if Earth did not tilt on its axis? Well, there would be no seasons. If we didn't tilt at all, everything would stay the same distance, the same angle from the sun. That the angle of direct sunlight would stay the same throughout the year. So there is no seasonal change if we didn't tilt on our axis. So what evidence shows that the sun's path through the sky is predictable or unpredictable? Oh, hold on. We need to finish in some of these blanks here. So seasons, as I just said as we were finishing up that last one, seasons are patterns of temperature changes over the year. The poles have the biggest or the greatest change the equator has the least. Yeah, the poles have the biggest or the greatest changes. The equator has the least. All right, so what evidence shows that the sun's path through the sky is predictable or unpredictable? Well, if something is predictable, that means that we can expect it to happen. Unpredictable means that we didn't expect it to happen. So, going back to our reading, if you were planning to build a house, you'd probably think about how the sunlight would hit the house at different times of the day. So you might think that you don't want to have your bedroom window facing the east if you're wanting to make sure that you don't have that morning sun wake you up every morning. Or maybe you want to make sure that it is facing the east so that it does wake you up very naturally in the morning. It all depends on what the direction that you want to be. If you think that you are going to spend time in the backyard, at the evening time and you want to have as much daylight as possible, then maybe you want that facing west. Or maybe you want it to be where you're growing a garden. You want to make sure that you have the right amount of sunlight. So where you are building something or growing something, you want to think about the sunlight that will affect that area. So you might want a sunny kitchen in the morning, so the kitchen should face east. You might want the sun on your deck in the afternoon, so the deck could face west. So you can plan how to position your house because you know that the sun always, and this is a big one, always rises in the east and sets in the west. That never changes, right? The sun always rises in the east and sets in the west. The sun's path through the sky from east to west each day is predictable. You know, if you look east in the morning, the sun will come that way. If you look west at the evening time, that's where the sun will set. So this is because Earth is rotating counterclockwise. So counterclockwise means the opposite that the hands on the clock move. So for thousands of years, people have used this to understand to tell time. So let's look at our notes and fill in some areas there. So the sun always, and this is a big one, always, let's even change our color here. It always rises in the east and sets in the west. So Earth is moving. Go back to our purple there. All right, let's do it a little bit lighter. Earth is moving counterclockwise. And you can see this here. So clockwise, if we were to show this on like the hands of a clock, if we were to plug in and say we had 12, 6, 3, and 9. 1, 2, 4, 5, 7, 8, 10, and 11, right? And so if we were to look at this, the hands of a clock go around clockwise, right? Now counterclockwise would be the opposite. So when the Earth is moving counterclockwise around the sun, we look at that in our other one here, that it is rotating, going counterclockwise around, and as it does that, it's also moving counterclockwise as it's rotating. So the sun climbs. Oh, now we need to go back to our reading because we need to read more on how the Earth is moving. We haven't got to that little area here. So, although the sun always travels from east to west around the sky, it does not always take the same path. So you may have noticed that the sun climbs higher in the sky in the summer than in the winter. The farther you live, the lower in the sky in the winter the sun will be. If you lived in Tromsø, Norway, which is above the Arctic Circle, you would not even see the sun for several weeks in the winter. This is because of Earth's tilt on its axis as it revolves around the sun. In winter, the North Pole is in complete shadow even as Earth rotates. At the equator, there are equal amounts of day and night. Midway between the North Pole and the equator, the sun is at its lowest or at a lower angle in the winter. As a result, there are fewer hours of daylight during this time of year. So, we'll get into more detail here and witness this, but the sun climbs higher in the sky in the summer than in the winter because of the Earth tilt. The Earth's tilt does a lot of things, right? So the amount of sunlight changes depending on the season. And so we have 4 main seasons, and we'll break these down. But September, or a fall equinox, that equi part, equal, right? E-Q-U-I. That equi means equal. So if we have an equinox, we have an equal amount of day and night. And we just had an equinox just at the end of September. But then we have our December or winter solstice. And that winter solstice is the least amount of daylight. And this is the start of winter. So the winter December solstice is the first day of winter. If that's the first day of winter, then that means that our September fall equinox is the first day of fall. And we have that here, first day is fall, start of fall. So if we then have a equinox, and then we have a solstice, then we have to have an equal amount on the opposite side of our revolution around the sun. So that's where we get our March or spring equinox. And again, equi, equal amount. And this, again, first day of spring. And then we have our June or summer solstice. And that's the greatest amount. So in the summer, think about this, why we have so much daylight? Well, that's because it's summertime. We are tilted the closest to the sun. This is the first day of summer. But sol, for solstice, that means sun. If you were solar powered, if you had a solar powered car, solar powered batteries, those solar panels, they are charged because of the sun. So in the summer, we have the greatest amount of daylight on our summer solstice, the first day of summer. In winter, we have the least amount of daylight. So that again is that sol, and that's the first day of winter. All right. So again, we'll take a pause here as we will then demonstrate this later on. We'll witness it, and we will then continue within our notes, finishing them up. So hopefully this helps break down some more details of our seasons and how they relate to our movement around the sun.